here the question is for the inverter chain, because the inverter are connected in series, right? Which is shown below. Find the minimum delay through the inverter chain. Consider the self-loading is equal to 1. And I have named the inverter as A1, A2, A3. The output of the A3 is connected to capacitance. That value is 21 C1, where C1 is the load of the first inverter. Okay, so they have asked to find the minimum delay of the inverter chain. Suppose if I want to find, you know the formula for the delay, right? So the delay is equal to, formula is n into f power 1 by n plus p. Okay, so here the 3 represent, n represent number of stages. So here the number of stages is 3, because I have 3 inverters, right? So the delay n is equal to 3. P represent parasitic delay, and so the parasitic delay is 3, because so usually you consider how many inputs are there for the inverter. So you have 1, 1, 1. So I can write P is equal to 3. Okay. So D is equal to 3 f power 1 by 3 plus 3 is your answer. So I need to find the value of f, right? So f is equal to G into H into B. So here B is a branch effort, that is nothing but 1, and H is nothing but output capacitance divided by input capacitance, so it is 27, and G is nothing but it is nothing but G1, G2 and G3, that is equal to 1, because it is a logical effort of each inverter, that is 1. So here the F is equal to 27, because if I multiply G is 1 and B is also 1 and H is 27, so you will get F is equal to 27. So if we substitute here, it becomes 3 into 3 plus 3. So the answer is 12. So here the delay of this inverter is 12. Consider the second question. Find the threshold voltage of the circuit which is shown here, and ID value is equal to 1 milliamps. So the ID is usually shown here. So this is your ID, and R value is 100 ohm. Okay, and 25F is equal to 0.7, and VT naught is equal to 0.8 volt, and this body effect value is 0.4. Okay, so what is the formula for VT naught? So the VTH, threshold voltage is equal to VT naught, okay, plus this gamma into root of 2πf plus VSB minus 2πf. Okay. So if there is no body effect, means this V source to bulk, this has to be 0. So if it is 0, you can see if it is 0, these two get cancelled out and you will get the value as VT naught. But if VSB is not equal to 0, okay, if it is not equal to 0, then it will causes a body effect. Okay, so this is second order effects. So here we need to find the value of VSP, right? So what is our VSP? VSP is nothing but Vs minus VB. So Vs is nothing but the current flowing through this resistor. So the current flowing through this resistor is 1 milli into R. R is 100. Okay. Minus, what is VB? VB is 1 volt. So we'll get 100 into this one is 0.1 minus 1, that is minus 0.9. So this is your use VSB. Okay, so since I have so you have a body effect, right? Since it is not equal to 0, so you have a body effect. So this is the entire formula. So you substitute Vt naught. Vt naught is 0.8 plus the gamma value is 0.4 and 25F is 0.7 minus 0.9 minus of 0.7. Okay. So if we solve it, we get 0.8 plus 0.4 into root of 0.2. So since it is some in terms of modulus minus 0.7, so you will get the answer as so I'm seeing this one. You can see the value of uh, the VTH get reduced. Initially it was 0.8, but now you can see it is this is 0.447 minus 0.836. So whenever this is so you will get the answer is 0.8 minus 0.1555. Okay, so you'll get answer is equal to 0.644. So you can see the threshold voltage get reduced. So next question there. So the ID value is given. ID value we need to find. So the VDS is equal to 5, VGS is equal to 2.5, VTH is equal to 1 volt, and this lambda is equal to 0.02 volt per 1 by volt. It is nothing but channel length modulation factor. Okay. So since it is given and they have given the transistor is operating in the saturation region. So since it is operating in the saturation region, so you have to know the formula. It is nothing but beta divided by 2 VGS minus VT the whole square into 1 plus lambda VDS. So this is the formula. So this beta represents mu n C ox W by L. Okay, and it is VGS minus VT the whole square into 1 plus lambda VDS. So you substitute this value. So you will get 100 into 10, right? VGS is 2.5 and VT is 1 volt. 1 plus lambda is 0.02 into 5. So it is 1000, 1.5 the whole square into 10, right? So 0.02 into 5. So 1.1. So 1.1 into 1000 into 1. So it is 1.25, right? That is that is 2.2, 2.25. It 2250. So you can see the I have made one mistake. So it is 200 into micro. So the micro value I haven't put it here. So it is nothing but 10 power minus 6. So why I am usually the current should not be in the um, should be in form of decimal values, right? So you will get uh, so 2. This is 2.25 into 10 power 3, right, into 10 power minus 6. So it is nothing but 2.25 into 10 power minus 3. So it's just nothing but 2.25 milliamps. So this is your answer.